All right. So, one of your last reviews, some of you asked me to go over a little bit about weather and climate change and the responses. So, uh, now we're going to start with weather. And actually, this morning we had a pretty awesome thunderstorm. Weather terminology, there's some basic things. Temperature, just so you know, is not a measure of heat. Heat is another way of describing temperature. Temperature is officially called the movement of particles. Faster moving particles on the atomic level have a higher temperature. Dew point is the temperature where water vapor condenses back into liquid based on humidity, and so you can actually use that to figure out the height of clouds using some basic science. It's whenever you see people describe like how they know how high clouds are, they're doing it based on humidity and the temperature at ground level. If you look at the cloud in this picture, if you see the flat bottom it has, that is really awesome. As you go up, this flat line shows the exact dew point. So right now, because we're getting into a warmer time of the year in Colorado, you'll see thunderheads forming. The bottom of the cloud tells you what the elevation is for dew point. It's at that temperature, water vapor condenses back into microscopic droplets to form clouds. And here are thunderheads forming. These are areas where the air is superheated, usually because of convection on the ground level or a darker surface on the ground level related to albedo. And so these hot spots cause columns of air to rise. And just so you know, the higher the cloud, the bigger the storm. So when you start seeing massive things that almost look like atomic bombs, that is a column of super hot air that has a lot of energy. And as it rises, it's going to cause huge storms. Air pressure is the amount of air per unit of volume. We have less air pressure here because we have less air per unit volume. Winds are high pressure flowing to low pressure, and winds are caused by convection. Convection is caused by the uneven heating and cooling of the Earth's surface. Here's a map of the air pressure from the 1991. It was called the Storm of the Century. It was two hurricanes collided with a nor'easter right here. All of those are super low pressure. When this weather map came out, their wave sensors in the North Atlantic were recording waves in excess of 100 feet, and quite a few boats were lost at sea. This was the storm that sunk the boat in the book, in the movie, The Perfect Storm. This is a satellite image of how that storm looked. That's an artist rendering of what it was like to be on the fishing boat, the Andrea Gale, when she sank in the perfect storm. Jet stream we talked about are bands of high winds in the upper atmosphere. Right where we are, the jet stream is usually pretty near us. This is why most of our weather patterns tend to come from the west. The weird thing is because we're up against the rain shadow of the Rockies, we sometimes have warm, wet air climbing in, causing weird weather here from other directions. Clouds, you don't have to know all the clouds. The two major clouds to know are cirrus clouds, which are the long, wispy clouds. That means it's going to be windy. And big, cottony-looking clouds that are cumulus clouds. The ones that make thunderstorms are cumulonimbus. And here you can see this cloud has reached the upper atmosphere and is flattening out. That's called an anvil-shaped cloud, and that means it's going to be a kiss your butt goodbye kind of thunderstorm. Pyrocumulus is awesome. I actually got to see this once, and it was the coolest thing. There are clouds formed from smoke. They generate red lightning, and the smoke can be from volcanoes or wildfires. They can actually spread fire during wildfires. So this is what I saw in northern Wisconsin from a wildfire across Lake Superior, 700 miles away, that burned in the Boundary Waters. The smoke ended up going all over Chicago, where it continued making pyrocumulus storms in Chicago, causing a bunch of people to call 911 in panic attacks. Some science for weather changes, which is good skills to have in the budding months of, it warming up outside. When you see a drop in air pressure, expect bad weather. This is why we're always concerned about air pressure. And going with air pressure, one way to know if it's going to be windy is look at an air pressure map. These things read like contour lines. If you know a contour map, the closer the lines, the steeper the hill. With an air pressure map, the closer the lines, the stronger the winds will be. Sorry. There we go. Another sign is significant temperature changes. If the temperature drops drastically, you're more likely to see things like tornadoes and thunderstorms. Green sky is also likely before a tornado, and that is not a bad photo. That's not color enhanced. Uh, where I grew up, we had a lot of tornadoes. When you see a pea soup green kind of sky, it usually means there's tornado weather. We actually don't know what makes the sky turn green. Physicists suggest it might be scattering of light on droplets because of things rotating in the upper atmosphere. We have no clue, but if you see a sky that looks like this, go inside and seek shelter. These we're starting to see a lot of in Fort Collins. Mammatus clouds, and mammatus is Latin for breasts. Um, these mean there's a tornado downwind of you. A few years ago at New West Fest, they had to cancel the shows on a Friday night because these formed right over the city of Fort Collins, and there was a tornado just over by 25. So good news is if you see that, the tornado is already downwind of you, but that does mean you have tornado conditions forming. Hail is also a good sign that there might be tornado potential. Hail is formed by little droplets of water flying up into the upper atmosphere, freezing a layer of ice and coming back down, gaining more water, going up in the atmosphere. And the rings you see tell you how many paths it made. The bigger the hail, the more you have of that weird vertical rotation. All it's going to take is for that shear to twist sideways to start forming a tornado. So if you see hail, that is a good time to get inside. Besides, hail just hurts really bad. This one I love. If you see a rainbow around the sun or the moon, they're called sun dogs and moon dogs, you can safely guess that there's going to be snow or rain in 24 hours. I used to upset one of my meteorologist friends by pointing this out to him, and he would refer to me as using a bunch of hippie folklore signs. I ended up finding out the reason why the rings form around the sun and the moon is it's high altitude ice crystals that are usually indicative of moisture moving into an area. So this is a good prediction. Lightning is hotter than the sun, and the electrical current can stop your heart. And I'm so sorry about that weird window on my screen saying AP stuff, but hey. One strange thing is if someone's struck by lightning, they're usually pretty easy to resuscitate with CPR. The main thing with lightning, though, is for lightning safety, if you hear the thunder, you are close enough for the lightning to strike you. So even if you do the whole, oh, it's 4 miles away, I'm fine. Lightning apparently can travel over 20 miles horizontally. So if you hear thunder, you should go inside. And here's a epically bad photo experience for these brothers. I think they're brothers. And this actually happened to me once back when I had hair. If you start seeing your hair stand on end, that means the charge is starting to build for a lightning strike. Right after this picture was taken, they were struck by lightning. They did survive. But if that happens, you should generally seek shelter or even consider lying down on the ground as one encouragement. That's even better to crouch on the ground. If you look online, there's directions for, I'm not kidding, the lightning crouch for safety. When this happened to me, I was with another researcher on a lake in northern Wisconsin. And as we were collecting stuff out of plankton nets, all of a sudden I looked over and her hair was standing on end. And she looked at me and my hair was standing on end. Fortunately, she was one heck of a boat driver. She got the boat, it was an outboard motor, started in one pole, and we beached that thing on the beach right as lightning struck the lake. So we were very lucky. For mountain safety, most lightning strikes happen after 3 p.m. in the Colorado Rockies. So you want to be off the mountains. You don't want to be on the mountains after 3 p.m. And they're starting to push that up to 2 p.m. now. If you hike 14ers, you really want to start early in the morning. Lightning rods are sadly a thing of the past. We don't really put them on houses anymore. We stopped putting them on houses because everybody was putting antennas on their house that serve the same purpose. There are other things that can kind of give you the equivalent treatment of lightning rods, which, excuse my hiccup there, includes things as simple as just gutters. But this is something to consider if you're going to have a taller house. Upslope. You hear about this all the time in Colorado. So here we are in Fort Collins. So just pretend you're looking south at Fort Collins. And this is when a prevailing wind pushes a mountain or a cloud of rain and moisture up in the mountains. As it goes up, it cools down and forms heavy precipitation. Usually in Colorado, our weather comes from the west. When an upslope forms, and when that happens, we're in the rain shadow. We're on the dry side here. But when we get an upslope, it's coming out of the Gulf of Mexico, and we get heavy precipitation, and that's when we get, the 3-foot snowstorms. In the summer, it means we often get flooding rains. So a trick my husband taught me is if you can smell the feedlots in Greeley and the slaughterhouse, an upslope is brewing. So tornadoes. They're rated on F1 to F5. F5 is really powerful. The nearest F5, I believe, was in Alt Windsor area about 7 years ago, I believe. They carry stronger winds than hurricanes, and we are terrible at predicting them. Here is a map of areas which have had tornadoes. So as you can see, we are right on the boundary. We used to say that we didn't get tornadoes. That model has been changing. One key for tornado safety is the best thing to do is find an interior basement room. If you don't have an interior basement room, climb into a room in the center of your house, ideally one with like a bathtub, preferably cast iron. And you can even put a mattress over your head. If you can pick up a mattress, those things are heavy. I just moved. So now on to climate change. You've already had this, so this is going to be fast. Remember, this is my high-tech drawing I showed you. All it is CO2 traps heat radiating off the Earth. Make sure you point out CO2 is trapping heat, not trapping sunlight. If it was trapping sunlight, we'd be a glowing ball. It's first described by a Swedish chemist named Svante Arrhenius, who is a total jerk because he also helped inspire the Nazi Party, so he's a jerk. With climate change, we talked about some of the evidence includes direct observation. This is the Keeling curve measured in Hawaii. The seasonal wobble that you see there of the CO2 going up and down, this is from the boreal forest in the northern hemisphere going photosynthetic in our mid to late summer. But overall, the trend has been going up. Longer term data goes farther back. This includes things like almanacs, weather stations, and everything like that. And you can still see the trend is going up. But this is what we talked about. This is not going far enough back in data. This is how we go farther back. The big thing is CO2 comes from ice bubbles. And this goes back 400,000 years. Here's a scientist saying, I'm going to torment you with my science. My buddy Keith got to do this for a little while in Antarctica. So when they pull out these tubes of ice from ice caps, they keep them in a freezer, they thaw thin layers, and it's showing a steady increase in CO2 going back 400,000 years. It's showing our CO2 level now is higher than it's ever been. But the other thing is the prehistoric carbon is a different isotope, the stuff from fossil fuels. The heavier isotopes ended up in fossil fuels sooner because they have more neutrons. So they're heavier. So we can clearly see that the CO2 is going up, and it's from combustion of fossil fuels. It's not from forest fires. It's not from anything but burning of fossil fuels because it's prehistoric carbon is what they call it. Temperature, this is what I got to do in college. I was playing lawn darts with parts of the ocean that were 2 miles deep. So these are tubes of sediments. They're about 4 to 5 inches in diameter. We would drop a gravity core. This thing was heavy. You had to use a hydraulic lift. And using a sonar, you'd lower it till it was about 300 feet off the bottom, flip a switch, and it would just skewer the ocean sediments and pull up the tubes. And then we would really carefully wrap them and never look at them again because they were processed by scientists at Woods Hole Oceanographic. There, they pull out the exoskeletons of these microscopic protists called foraminifera. The foraminifera contain their exoskeleton contains calcium carbonate. The carbon, which is CO3. We actually are looking mostly at the carbon gives us a hint for age, can soak in the layers of the sediments. We're looking at the oxygen. There's 2 oxygens, O16 and O18. O18 has 2 extra neutrons, it's heavier, so it's called heavy oxygen. Delta O18 ratio tells us the ratio of O16 to O18. Delta means change. So we're looking really at the change in the O18 ratio. The more O18 you have, the cooler the planet was. So if you start with a cool planet at the end of an ice age and start working your way up, you'll see the O16 and O18 levels fluctuate. And we haven't done this with just a few sediment cores. We've done it with all of the major oceans. My mom pointed out we don't have a good baseline because she's like, no one in the Western Hemisphere has collected temperature for more than 100 years on a daily basis. And that's right, we haven't. But fortunately, we have the other half of the Earth, the Eastern Hemisphere, where Buddhist monasteries have temperature data going back over 1,000 years. And those data actually are the baseline that shows that the delta O18 ratio is a good calculation. So when we're talking about climate change, we got to talk about the things to deal with. So there is a quote from someone who should not be making important decisions. So these are all the things we have to deal with. We also have to reduce CO2 emissions and try to get some of the carbon that's in the atmosphere currently out. Sea level rise, it's going to come from two things. Ice melting, but it has to be perched ice sitting on land. Floating ice, when it melts, does not raise sea level. It's the stuff on Antarctica and Greenland is our problem. Thermal expansion is also as you heat water, it expands. And one thing that Art Samuel, a guy I've worked with from the College Board for years, Professor at Bowling Green University, pointed out is sea level isn't gradual. Sometimes the tide comes in and doesn't go out, which was weird to think about. So the sea level rise of even 4 feet by 2100 would be problematic. It would cause relocation of about 10% of the world, increased insurance claims, loss of life. Florida has already had a significant drop in real estate value because storm insurance is now so expensive. The houses are, everybody's selling their houses because the storm insurance is bankrupting families. Normal homeowners insurance does not cover you for floods and hurricanes. You have to get flood insurance. King tides are what we now refer to as sea level rise. My sister has these in Connecticut, and she's like, we're getting more king tides than ever. And she's like, what's causing them? And all a king tide is a high tide that's higher than normal. The reason it's higher than normal is because sea levels have gone up. So these are ways you deal with it. You have to build seawalls. You have to raise houses. Raising houses is really expensive, and even this is only going to buy you a little bit of time, because as sea levels continue to rise, once the ocean is underneath this house, that house will be condemned because they can't have utilities. It's also expensive, and how's grandma going to get up those stairs? So seawalls, they keep water up, but they prevent water exchange. So this is common in places where sea level is problematic, but when you do this in places like Venice, you trap some pretty nasty effluent in that city. Raising streets, and some of my friends in Florida are like, oh, it's great. We're like, we've solved sea level rise because we raised our streets. And you have to explain, well, if you have a storm surge at sea level rise, you can still get around, but everybody's still going to flood. You just have a place for fire trucks to get by. Raising streets is really for emergency response and evacuation. It's not fixing the problem. We're also seeing increased storms and extreme weather. So here is a picture of the jet stream a few years ago when some of you were trapped in Florida for winter break, and it was so cold the iguanas were freezing and dropping out of the trees. That's an allergy cough and from talking too long. Sorry. And it's important to understand why people start dying. And I showed you this ominous graph of when we talked about climate change. And what we're seeing is actually an increase in cold weather days and an increase in hot weather days. What we're losing are these pretty days in the middle where no one dies. People die from heat exposure, storms, and dehydration when it's too hot. People die when it's too cold from loss of infrastructure, loss of water, roof collapse, suffocation, icy roads. Where I lived in northern Wisconsin, the roads were covered with 2 inches of ice my last winter up there because for 3 months, there was not a warm enough day for the salt to melt the ice, as well as hypothermia. And even things like you can get ice caps over your furnace vent that fills your house with carbon monoxide. So we talked about how it can get colder just by the shifting of the jet stream. We also have increased droughts, agricultural issues. Now the changing climate, we're seeing timber stands at their southern edges in the northern hemisphere dying off. So there's foresters now trying to find ways to help those forests migrate north by planting the seedlings farther north. They're doing it currently with the sequoias along the Pacific coast. This came from the New York Times. Mass migration, in case you didn't know, the U.S. doesn't have a good reputation for dealing with mass migration. Here are people in the U.S. fleeing parts of the U.S. because of the Dust Bowl, and not only did no one help them, but a lot of people took advantage of them. There are some really simple solutions. Reducing your carbon output, removing carbon from the atmosphere, and deal with rising sea levels. Here's some good news, though. We are switching to carbon neutral energy at an accelerating rate globally. Looks like this year, for the second year in a row, we will have a period of time where we're using more renewable energy, carbon neutral energy in the US than coal. Um, so some countries are almost now entirely carbon neutral, like Costa Rica. We have Fort Collins and Boulder in a bro fight to see who's going to go carbon neutral first. Even though they seem like two relatively small communities, those two communities have a lot of engineers, a lot of money, and they're one of the major economic producers for the state of Colorado. So if they want something, it will go statewide. It is the fastest growing job sectors in the US are becoming wind and solar energy, including in Kentucky that used to be coal country. Now, finally, what can you do? You often hear about these problems and you're like, oh, it's too late. I can't fix it. There's nothing I can do. I hate this class. Um, One of the easiest things you can do is remove all palm oil from your diet. The second biggest source of carbon dioxide in the atmosphere is palm oil plantations from the clear cutting and burning of forests. Um, so palm oil plantations are also linked, just so you know, with increased bat viruses in the human population as we displace bats. Um, so get all palm oil out of your diet and skincare products, which means you have to read the ingredients. That actually would make a huge difference. Reduce carbon dioxide emissions. I mean, you're in high school, some of you are starting college. Your carbon footprint is going to be relatively small for a while. So just think about things like removing palm oil. But the other thing you can do is plant trees. If the average American plants 5 trees a year, it offsets the carbon footprint for driving a car for life. So there are some really simple things you can do right away. Also, most of you will be able to vote in the next election. So when you get to the point where you can vote, vote what you think your policies are. I'm not telling you how to vote. I'm just saying, look at the candidates, see what they're talking about. And so ends your instruction for climate change. I miss you all.